Okay, this is number 18 in section 2.7 AP Calculus related rates. We have a depth problem. A conical tank vertex down is 10 feet across the top, 12 feet deep. I tried to illustrate that with a drawing. Water is flowing into the tank at a rate of 10 cubic feet per minute. Again, I tried to illustrate that right here. Find the rate of change of the depth. So they want us to find how fast the height or the depth of the water is changing. So they want us to find dH dt. Nowhere in there is R mentioned. So I might need to try to replace R. So I'm going to have 1/3 pi R squared H. Now I would like, as the water is flowing, it's going to have a certain radius and a certain height. Do you agree with that? These are similar triangles. So I don't know how you want to do it. Big radius to big height as small radius is to small height. There's lots of correct ones, but there's also incorrect ones. How would I solve this for R? Well, I would have 12R equaling 5H. 12R equaling 5H. So R is going to be 5/12 H. So I'm going to put 5/12 H. When I square everything in the parentheses, you're going to get 25H squared and 144. And times this H. So now I'm going to have 25 pi, I believe, over 432. H squared times H is H to the third. I now have volume in terms of height, which again might be part of a question. Can you express the volume in terms of the height? Well, I hope so, or else you won't be able to do the rest of the problem, because now we're going to find the derivative dV dt. 25 pi over 432, which I'm writing this way. Those are all constant factors. Power, base, 1 less power, derivative of the base. I wrote the 432 that way because I knew those 3's might eliminate each other. So I get dV dt to equal 25 pi over 144 H squared dH dt. At this point, I'm going to plug in any of my instantaneous values. I'm trying to find dH dt, so I leave that in the equation. What is dV dt given to be? 10. If we read the problem, it says find the rate of change of the height when the depth of the water is 8 feet. So at that instant in time, H is an 8. So now all I have to do is solve it for dH dt. I may make a little room, and I'll be right back. I just rewrote it. 8 squared is 64. 64 times 25. 4 times 25 is 100, and then you need 16 of them, because 4 times 16 is 64. Now you're going to multiply by your reciprocal. The reciprocal being 1600 pi over 144. No, the reciprocal would be 144 over 1600 pi, right? 1600 pi. So what would that give me here? Top times top, 144 with an extra 0. 1600 pi. Cross those out. Gives me 144 over 160 pi. I'm going to simplify it, so I'll do half the top, half the bottom, half the top, half the bottom. We could do this much faster. Half the top, half the bottom, half the top, half the bottom. So now I'm at an unsimplifiable form, so I get dH dt equaling 9 pi over 10. If the volume is in cubic feet, the height is going to be in feet, time is in minutes. So this should be the answer for number 18. Sorry, I had the pi on the top. The pi should be on the bottom here. And yes, this is the answer, 9 over 10 pi feet per minute. So this is correct for number 18.